Well, hi, good morning, and thanks so much for joining me here in my shop. Today is December the 3rd. It'll be my second day on this radio, and I think today what I'm going to focus on is 5 capacitors that I'm sure are worthy of changing. And here they are. There's one here, electrolytic one here, another electrolytic one here, probably worth changing. There's a big old molded thing you can kind of see here. There's another round molded capacitor just kind of behind the tube here. That's 1, 2, 3, that's 4. And number 5 would be this guy up here. So the first one I want to look at a little closely is this guy here. So this is an FM radio. FM radios almost always have a small electrolytic capacitor in the detector. 2, 3, 4, 6 microfarads. This one's 4 microfarads. So I'll bet you this is in the detector, FM detector. It's in the right location in the radio. Something else that's kind of interesting here is this strange plastic sheet on which they've mounted a few components. Oddly enough. Why they chose to do this, I don't know. Well, I'll take a wild guess here that after designing the radio and building one, they concluded something was coming up short, and to correct it, they came up with this little circuit. But to fit the parts in, they couldn't go on here. So they fit them on a piece of plastic and kind of soldered them in at the bottom there. Sort of worked them in. My guess. Just a guess. Another thing of interest is this resistor, which appears to certainly have been overheated. Feels like it's all there, but we should really check this guy out too. I think I pointed out he's up on ceramic supports to lift him up off the board because they know he's going to be hot. Well, there's another one. Look at this one. It's also up on supports. This one doesn't show any sign of heat in it though. But there is another one. I don't know if I can get this on camera too easily. Straight down here, there's another one that's up on ceramic supports. That one looks a little darkened on one end. So my thinking there is the designers knew these 3 resistors, maybe there's more in there, were going to run a little warm. And so that's what these ceramic supports are for. And that's a hint to me that all those resistors may have gone high in resistance. So we'll see if we can find all this stuff on the schematic. We'll start with this guy. Okay, so this is the second page of a 2-page schematic. The other page is over here. So here we've got clearly this is the detector. You can see the what's that? That's what's this? What is going on here? I guess this is how they're marking cathodes. Another little dot there. I guess this represents the cathode. I mean, the cathode in a tube is a round item like this. And then how many different cathodes are there in this? Okay, but in any case, that's got to be the detector tube. And here we see it's a classic FM detector arrangement here. Resistor. What's so classic about it? You have the 2 rectifiers here in opposition. Can I say that? Maybe that's not the right way to put it. You're going to build up a small voltage on this. Look, it says 4. So this is definitely the capacitor I'm looking at. This is a critical part of making FM sound really good. If this gets weak, the FM quality will go down. Now there needs to be an FM detector coil. This must be it here. I'm sort of jumping ahead a little bit. While I'm here on the schematic, trying to sort out where so maybe it's a little more complicated than most. They seem to have two of these. There's a little tiny takeoff in here. Don't know what's going on. But there'll be a coil, and in the German instructions, it will explain in German which one of these is the coil that there's probably a proper name for it, and I don't know what it is. It's a coil that you use to convert frequency modulation into amplitude modulation. Ultimately, you need amplitude modulation to drive the speaker. You can't FM it all the way to the speaker. At some point, it's got to be converted to amplitude modulation. That occurs in a coil, in an adjustable or tunable coil. Okay, that's enough of that. So we know what this one is. Now there was another one. There's the blue electrolytic capacitor, the value of which I cannot read the way it's mounted in the radio. It looks the same as the 4, but I think it's this one right here, and that's a 50 bypass on this cathode resistor. Now, is that the resistor that's gone hot? 330 ohms. I'll bet you it is. We'll check that out in a minute. The other capacitors, it takes quite a while to sort out which one of all these capacitors you see in here are the few big ones I want to change out, so I'm not going to bother with that. Let's see, 330. We'll go back and look at the radio and see if that hot resistor is 330 ohms. So it's this guy. So yeah, you know, that could be orange, brown very easily. And it's right in position. Let's check it with an ohm meter and just see how we're doing with that. As soon as I can find my ohm meter here. Wouldn't be surprised if this is 400, 500 ohms. .337. So it's still bang on. It looks overheated. Yeah, it has overheated, but it hasn't actually caused it to distort. Distort. Kind of a funny way of putting it. Okay, let's look at the other resistor then. It looks like brown. Then the next color looks black. Orange. Brown, black, orange would be 10K. So let's take a measure of this other guy. Hold still, meter. Don't go anywhere. Really? Exactly one. Hey, what's my meter doing here? Something funny going on. Open. Okay. I think it's what did I say it was? 10,000, didn't I? Third band is orange. Exactly. It's just kind of weird. It goes to exactly. And what is that? That's 1,000. 1,000. Wait a minute. There's something funny going on here. It's not going on in the real world. It's going on in my head. What's going on in my head? 1,000. So this resistor is obviously in a circuit with other components. So yeah, 1,000. So that would be one reason why it would read only 1,000 when it says 10,000 on it. Again, I'd have to hunt. I'm looking for an open circuit there or something like that, and the resistor really doesn't look that bad. Feeling the surface of it? No. The resistors develop a hot spot inside them, and they'll burn through like at one end. And one end can be quite destroyed when the other end looks really pretty good. Sometimes you can't see these things easily. You gotta kind of feel them. Okay, so the name of the game is leave the resistors alone. Get on with this. And the others. I think what I'll do, I'm trying to think of some objective way of knowing when I change this that the radio operation has improved, or the opposite, it's gotten worse for some reason. I gotta think about that for a little bit. Okay, so as usual, European radios are really complicated compared to North American radios of the same vintage. Wow. I mean, can you fit more capacitors in here? Holy smokes. So let's start with the FM antenna, since I'm curious about the FM detector. So everything, just a dipole antenna, basically operating this transformer. And they have some fancy stuff here. And what is this though? So one leg is extended down through a coil to this. What is this? A switch? 1K resistor. And what is this? So this is the shortwave antenna. This represents like a wire hanging outside your house type thing. That's obviously the ground connection. So the long wire feeding through this overly complicated schmozzle here to feed into the broadcast and shortwave band and drive it. I suspect this is the cheater way to use this antenna as a shortwave antenna. You just slide this lug over. This is on the back of the radio. Unfortunately, I look at the back of the radio, I only see two possible positions. I don't see the third. So you got so you're selecting the input. Well, this is always hooked up through here. So you're selecting either, for some reason, why would you do this? Why would you put a 1000 ohm resistor on your antenna? Don't know exactly. So that's one option. Another option is feed in whatever's coming in on the little FM antenna. And the last option is switch this over here where there's no influence on this antenna. This could be a distance and like a way to cut down the signal for very powerful nearby stations. But this is not handy. This is on the back of the radio. You need a screwdriver to change this. This is like a one-time change. You decide once what you like and you leave it. And as I said, I only saw two terminals. I don't know how the thirds. I don't know how this is working on the back of the radio. Now, is it necessary to sort it out? I think it would be helpful. My plan is to feed a controlled FM signal into here. And using the controlled signal, I can then observe the output from the radio. When I make a change on that capacitor, I'll see a change in the output. The difficulty with that is that this is all about how the radio sounds to your ear when you're playing music on FM. That's the real issue. And putting in a single tone and listening to it is not going to clarify whether the tonal quality of the radio has been improved, which is really what I'm after. So I don't know how to get there. Don't know how to get there yet. So part of this is hooking up an output meter to measure how much signal is reaching the speaker. So it's just putting a voltmeter across the speaker basically. And the speaker circuit is in itself isolated from everything else because it's on the secondary of this output transformer. But in this radio, like a lot, this side, it looks like it's tied to the chassis. And this side looks like a feedback circuit feeding back, yeah, sure, into the volume control here and all this stuff. So this is a distortion reducing feedback here. I put my meter on and put the grounded lead here, that's not going to be good. I got to put it here. So I have to figure out which side of the speaker is this ground on. Now you can hear a radio playing. It's another FM radio in my shop that's playing right now. There's a reason why it's on. So let's just check the meter here. Today, 0 is there's a 0.1, all the way down to 0.1. Okay, now so this is always hard to do. Tell the difference. So this is one voice coil side. I saw a 0.2 there, 0.2, and the other voice coil, is it going to be any different? I saw a 0.5, 0.7, oops. Okay, so I think from that I can assume this orange one is the grounded terminal. Got my output meter here. The grounded side. So my idea here is feed a signal in from an FM supply. This is an FM signal generator. Send the signal in, get everything stable, measure the result at a typical audio frequency. I have a selection on this device. I can 400, 1,000, 5,000, or even 19,000, which we can't hear. 19,000 has a special effect on shortwave on FM radios, but not this one. This is not a stereo radio at all. So we can go through the 3 frequencies that it can modulate the signal at, read the strength on the speaker, record all this, try to change absolutely nothing except one capacitor, and then repeat that. What's it going to tell me? I don't know. It'll probably tell me to never try this again. That's probably what it'll tell me. So this guy drifts. He's got to stay on for quite a long time before we do this. So I'm going to go and hey, where's my cats? They haven't even dropped in today. What's going on? Okay, just about ready to go. First thing I want to do though is kind of verify the operation of my signal generator there. So I do have another FM radio in here. It's this guy right here. You see it's tuned to 100.1, and the sort of the normal output frequency of this is 100. So this is the adjustment for frequency. Okay, now things are going quiet because I'm not modulating the FM signal, but I will now just by turning this knob. This is showing, okay. This is showing a 75 kilohertz sweep range, which is the normal maximum in an FM signal, as I understand it. So we're listening now to 1,000 hertz coming out of that nice radio up above. 400. $5,000. We're going to turn off the 19 kilohertz carrier because this is not a stereo set. No reason to have it running. And that's the highest tone I can pitch at the radio. So what I'll do now is I'm going to do the same thing, only receive it on this radio, measure the volume here, see how stable we can do this whole thing. So we're going to turn this guy on first. It's okay. There we go. So I'm going to turn the other FM receiver off so we don't get confused. Off. There we go. So the only thing we're listening to now in here is this. So I'm on broadcast radio right now. I'm wondering why I'm not hearing anything. A little wee bit there. What's happened? Get the volume up full. Maybe it's the push button here. What's happened to you, radio? I'm definitely on broadcast. Oh, look at that. Tuning works. After loosening it up. Perfect. Feels great. Feels perfect. I guess the solvent worked overnight. How about receiving something though? Tube thing happening again? Bad actor. Okay, I think that got it. Sure. So switch to FM now. And we'll look for right around 100 here. Where's the pointer? Pointer's right here. That's the pointer sliding on the... Sounds like a signal. Well, I didn't hear it. So we're right around 100. The output of the signal generator is just terminating, and it's not even terminating. It's just ending up here, just hanging here in the air. It's not connected to the radio. Oh, I know what happened. The little antenna I put on popped off. Right. Okay, so we'll put on just this little piece of wire and throw it generally in the direction of the other one. Wrong one. Oh boy. What happened? Now, we were listening to FM the other day. Were we not? Didn't I not? Okay, so it could be... nothing at all. I'm sure I listened to some weak, very weak FM, if I remember right. Very weak. And it had a bigger antenna on it at that time. Right, I had the big antenna up here on it. That's right. So let's do this. We'll more closely couple the output of the signal generator to the FM antenna here. Still not directly coupled, just doing the proximity thing. Let's try again. The output here. Oh, it was minimal. Now it's maximum. FM RF output. Hey, come on. Something's not working out here. Huh. Well, we'll just assume there still isn't enough signal. So we'll make a direct connection. Let me turn down that output level. Make a direct connection on one wire first, not both. I think I hear something now. Yeah, I'm hearing. Oh. So this is up on 5. Put it down on 1,000 hertz. I heard it. Sort of came and went in a weird way. Now it's just, the cane part is gone. Now it's just went. Jim, you're not running it on full voltage. Da 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 da. Da 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 da. Come on, you're supposed to jump to life now. That's what happened last time. Up on the RF level, I turned it down. Up it. Oh my gosh. What has happened? Okay, so what we'll do is we'll attach the ground line or the other. Oh, what just happened? What? Is this tube again? It's just caused me too much trouble. Okay, we have to revert to dealing with those tubes. Cannot live like this. Every time I turn around, it's a tube contact problem. How can these tubes have such bad contact? How hot is this? Not hot at all. It's just nicely warmed up. So my experience, so these tubes pins are a little gray. My experience is tube pins. So I don't know if you can see this. Can you see the shiny flat on? As I rotate it, you'll see it's hard to see in the camera. A flat spot, right? Where by wiggling the tube, I have scraped it. And I can see I've scraped it quite clean in every case. So why are you still acting up? Shove down. When I go to wiggle it, as I pull it up, the part that's being scraped here is actually not the part that's in contact when the tube is right down. So maybe that tube scrapey thing, although it usually works for me, won't scrape quite high enough on the pins to overcome whatever the problem is. And I'm making lots of assumptions here about what the problem is. Don't ever use sandpaper. Sandpaper leaves grit. Now, I could easily be cleaning off parts here that don't even come into contact with anything. Actually, I know where the flat spot was where I did this. So one of my mentors years ago said to me, what you do with this is you spray WD-40 on it. WD-40 again? Yep. Stick it in the socket and wiggle it around a bit. Okay. I'm not going to do that right now. We're just going to try and see if this fixes things up a little bit. And you go, on you go. Okay, let's go full. Full voltage supplied. A couple of pops. What do we got? So we're still on FM. Pretty quiet. Totally quiet. Tune a little bit. Anything happening? Volume up. Nobody's home still. Well, let's wiggle the tube. Maybe there's something more going on here. That seems pretty good now. What was that? Another band. Let's try another band. Volume down. Broadcast. Something going on here, I think. You know what? I thought a bit about breaking the trace onto the board. I think there's something more going on here. I've never had a tube give me that much trouble, noise-wise. Oh, this is pretty bad too. Huh. Is that normal? That would seem normal. This tube? That's the output tube. Is it not? It must be. It must be the output tube here. Okay. Sounds great now. Okay, leave it all alone. Push FM. She's dead. She's dead and gone. How could that be? Dead and gone. It's something. Yeah. Okay. I think I've seen enough to say it's not just simple two-pin contact here that's causing a problem. It's something else. Just when I'm getting close to doing something interesting, something interesting shows up. Flip it up on its side. Go up on that end. Just for double safety here, I'm going to pull the plug out. So if it's a break in the trace or something like that, this would be quite a process to spot it. So the tube involved is right there. That's the socket. Okay, so what I'm going to do, I'm going to get the close-up camera set up really close to it, and we're going to examine what's going on. Yeah, it's not the best looking solder job here. I'm missing a little bit of it here. Okay, now watching that, I'm going to start wiggling the tube. I'm wiggling. You can see that the board is twisting under the rotating wiggle I'm giving this thing. That big thing right in the middle is like a ground contact in the center. A couple of these are a little out of focus here. Continuing to move. I don't really see anything moving under here except the whole board is flexing. So now I'm looking along the traces away from the tube. Looking for a break, literally a break in the solder. So I don't see anything. So what I'm going to do is I'm going to resolder this whole area of the board here. Sure doesn't look good there. I mean, it looks like that. Of course, you don't know exactly what I'm talking about. Put it dead center of the screen. Oh, okay. So it's just some Well, there's two, right in the center of the screen now, there's two contacts. There's one piece of wire sticking up, got some brown junk around the bottom of it, that's got to be rosin. The one below it looks like a cold joint. Does this look like it's been redone once already? Somebody had trouble here? It could be, you know, in the factory after they flow solder this stuff, they find problems with it, and then they get out their soldering iron and touch it up. And that's exactly what I'm going to do here. I'm going to get out my soldering iron. And I'm going to touch this guy up. Yeah, I'll just go ahead and do that, I think. So on this long shot, when you look in this area, it doesn't look right. It doesn't look quite the same as the rest. It looks like something has happened in here. So I wonder if that is the case. It's been resoldered once already. Let me get my soldering iron out here. So it's a bit of a long shot. I can't say I saw anything that looks like a break. It just looks generally quite bad. So what we'll do is we'll so it's actually over in this area. This is the actual tube here. Tube in question, definitely. So we'll do this guy. Could be moving the tube is flexing the board and causing problems adjacent to the tube from, you know, to manifest. These all look just fine. Mind you, I'm not up close to it now. Solder's hard to look at. These all look great. Up this way. So I'm just doing the pins first. This one doesn't look so good. Okay, now over this way, things look kind of wonky too. The problem with doing this is that I'm really almost as likely to introduce this kind of problem as I am to solve it. And we are still going on the basis that I'm assuming this is the problem. Get them all in the vicinity. Okay, redo this trace here. Take a closer look. So hard to look at solder. Well, There's a big thing. What's that big thing? Big things don't solder well. Okay, let's give the radio another try. Whoops, whoops, whoops. Whoops. Okay, get rid of the solder. Okay, FM signal here, coming around. Let's put on the antenna. Just one side, just to restrict the amount of juice getting to the radio at first. Volume down. Start on broadcast, power on. Wait a minute, plug in, plug in. Hey, I remembered this time. Down, power on. Okay, everything's good. Who's buzzing? Jeez. There's something in here. The radio's become very sensitive now. Okay, take the opportunity. So, I mean, the whole thing is sensitive, right? So just because I tapped a particular thing, it doesn't really mean that thing is the thing. I just lightly touched this capacitor. Tube doesn't seem to be so significant. They didn't do much with the other tube here, though. We're on. Oh, I had the volume turned down. Duh. Duh, 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 duh. Okay, we're cooking. Good show. Okay. Sounds great. FM now. Ooh. Oh, hey, there's a little bit of FMing there. 100? Come on. Come on. You can do it. Okay, up on the RF output here. Come on. Nothing. How did I end up listening to stuff on this the other day? Because these tubes are still not, something is still up over here. I'm just going to apply vertical pressure here. Well, that doesn't seem to do anything at all. That's gone really quiet. It's too quiet. A nice hiss, nothing else though. Holy smokes. So what was it I touched that was so hypersensitive down here? Yeah, it just could have been anything hanging on the edge of, you know, making contact or losing contact, and I just pushed it over. Now the radio is very consistent. Consistently bad. Well, I guess put a stronger FM signal into the radio. So what we'll do is, because I've only got it kind of half in there right now, I'm going to take the, first I'll turn down the output here. Go right on the antenna. And then the other terminal. This is now going to feed a very powerful signal into the radio if I wish it to. Should hear it right now. Oh, jeepers creepers. Where'd you go, man? Am I confused? Did I never hear this radio work? I'm sure I did. Okay. Well, we'll just hit it with the more oomph here. Okay. It's full oomph. There's nothing. There's something. Okay, what happened there? He says loudly. We heard it right in here. Okay, so we can find out what it is now. I'll leave this here. Turn that down a little bit. Okay, tubes first. No, there's nothing happening there. We're hearing some output. The hiss. Earlier on in the scheme of things. Maybe this guy. Or maybe it's the FM tube itself. I haven't wiggled this one yet. Speaking of the devil. Volume down. Okay, we're going to give him the treatment. Before I burn my fingers. There it is, the treatment. I didn't like the treatment very much. Okay, we're going to pull it out. Now, if there's anything going wrong inside this FM tuner box, there's not much I can do about it. I don't think I'm inclined to try to get inside this thing and make changes. So if there's, and there likely isn't anything to do there. Just get a little protection here. It's a hot tube. Hot, hot, hot. This tube has 2 heaters in it. It's 2 tubes in one. So it's pretty hot. Looks really nice, the pins. The pins look nice. Looking down in the socket there. Hard to see in the camera. It's very dark, like a lot of dirt or something in there. Why would this one be particularly dirty over the others? So, tube contact problems in this radio seem to be endemic. Okay, I gotta wait a little while for that tube to cool off. I'm gonna see what my cats are up to. Where are they? Okay, so I've taken every tube out, cleaned up the pins, and I think maybe I've solved the tube problem. So we're gonna find out right now. Are we? Are we gonna find out? Yes. Broadcast band. Looks like I gotta do switch cleaning next. FM. Boy, boy, oh boy. Nothing is stable here. Nothing is stable at all. So, let me go back to broadcast. Oh, turn the rate down. Let's go back to broadcast. Give the tubes a wiggle. Good. Oh my gosh. That sounds a lot better. There's just endless problems with these tubes in contact. Let's go back to FM now. Oh, tuning the wrong knob, Jim. You've been tuning the wrong thing. We got it. We got it working here. Okay, I'm blasting a signal into this radio, so we're gonna unblast it here. That's probably more in the range of a typical. Wrong knob, wrong knob. So one of the things about receiving FM is that things should be very balanced as you tune through the signal. A lot of radios that give you a response, it gives you a little bump, then you get the main response, then you get a little bump. Those things should all be nicely balanced if they're there. And certainly tuning through it should be a nice thing. Let's try it. Wrong knob, Jim. Okay, tuning through it nice and steady. Let's try that back. So it sounds like there's some distortion in there. I'm not worried about that. Does it sound balanced as I go through it? Does it help you to turn the right knob? Let's try that again. So I see it. Just using my ear in that, yeah, that sounds pretty balanced. Hey, let's listen to a station. We can't judge anything from these tones. Although let's just give it the 5 kilohertz tone here for a second. Ah. Very distinct sweet spot. Do you hear that hum kick in? Right there. That's another characteristic of FM radios, which I don't fully grasp why they do this, but FM radios can hum between stations a little bit, or hum when you just tune them off like this, in these old radios. Good. Okay, well, it's reproducing 5 kilohertz loud and clear in my ears. Fantastic. So now we're ready for the actual experiment, which is not really an experiment, it's a repair, and I just want to be sure of the result. So to do this, the radio shouldn't retune during this process. It's just changing one capacitor. So what I'm going to do is I'm trying to think of how I can do this in some reasonably reliable way here, which is measure the voltage produced for each of these 3 frequencies. Just read it off the meter here. Don't touch anything. First I got to make sure this is tuned as good as it can be. I think I already did that, didn't I? Let's put this down to 1000 here. Tuning it. Make sure it's tuned in. Oh, you can really hear the tonal change. Can you hear that? You can hear the higher harmonics in there. And then it's just beautiful right in the middle here. Kind of tells me I'm not overloading it. Plus the meter goes up only so high it comes down. So I mean, it's the maximum reading. That's what I should record maybe. Maximum reading. Tuner right there. Don't touch anything. I'm afraid we'll have to listen to this tone now. So that's 2, 5. So point. So this is 0.1 out here. This is 0.028. 0.028. And that's with 1,000 hertz. And I'll go down to 400. I mean, there's lots of things can affect this meter reading, so we're not really the meter reading absolute number, it's the change of it and of the comparison. So now we're up at 0.045. 0.045. 0.045. It's a pretty small voltage, I got 400. And now we're going to go way up to 5. And at 5 kilohertz, we get 0.024. Okay, now I'm trying not to change anything, but I'm probably going to mess this up. First, just rotating this. Is this enough to throw everything up and down? Probably going to change the antenna position a bit. A little bit of a change there. Well, it's about the same. But I can't do the work like this. You have to move the speaker out of the way. Okay, power off. I gotta do this. Swing the radio this way. Under it too. Power's off. Yep, let's pull the plug to make sure. Just a little extra safety step here. Okay, this be the guy. He's got to go. We're going to take him out and we're going to test him. I'm going to try to leave enough wire above here that I can make the replacement above. I don't have to get underneath this board. So we're going to try to just nip off. Leave behind as much as I can. Not very much. This side here. Make a note. Which side's positive? Make a note. A nice plus sign right there. Positive that away. Okay. We're going to try and test this. Now, I don't have a lot of experience with testing electrolytic capacitors, but we're going to give it a try here. So I need to flip this switch like that. Now it's been adjusted to be calibrated to read electrolytic capacitors. Be careful about the polarity. Positives in the middle here. Positives here. And then the negative is just basically the shell, I think, really. I think I got it. Okay. So I'm going to put 50 volts on this guy. How much is it? 70 to 80 volts. This is all you can really do with this. So I'm not sure what to expect here. So it looks fine in terms of leakage. So now we're going to make a measurement of its capacity. So this is a 4, so we go on the 0.1 to 50 scale. Adjust this until the eye pops open. Doesn't pop open all the way. I realize I got my phone in here when I shouldn't. It's not opening up all the way properly. Now, maybe that's because it's electrolytic. Okay, so it's this guy. So this is a power factor adjustment. And exactly how this works, I can't explain it exactly, but you are supposed to adjust this. But I didn't think you were supposed to do it on this test. So that's where it is. the scale we're on is 0.1 to 50. There's the 50, 10, 5. So it's pointing at 5. But it says on it 4. So now how precise are these capacitors? Yeah, these are not super precise capacitors here. Electrolytic capacitors. See if it makes any statements. Good, minus 20 to plus 70. 70 to 80 volts on it. 4. Doesn't really say anything else on here that I can get anything out of. Generally, a leaky capacitor will fool these testers into reading a higher capacitance than they have. And that's probably what's happening here. I'm going to guess as an electrolytic capacitor test on here it's passed from a leakage point of view, but I suspect it's not as good as it could be. They've changed these particular capacitors, the one that's in the detector of FM radios in the past. It's almost always had a beneficial result, and stupid me, I didn't play a radio station so we could hear the quality of the sound. We're stuck with those tones, but that's all. That's water under the bridge now. 4 microfarad, I'll stick it in there. Okay, so I've put in a 4.7 microfarad capacitor because that's what I have. Tray of little capacitors here, and now it's time to start everything back up. So this is all here. Let's swing this around like that. Get a few tools out of the way here. Okay. Power on the radio. I unplugged it. I'll get it back in. Okay, all is normal. There we go. So what we're hoping is, because unfortunately we didn't listen to it first, that was a big mistake, is we're going to get those tones. Doesn't sound stable, does it? There's that hum. Okay, now I don't want to tune things. I don't want to change things. What am I supposed to do here? First, there you are. That's how you get it going. So you'll bang it in the side. The last time I tuned in for maximum at 400. Let's start at 400 here. Opportunity knocks. Okay, just with the width, just with the mass of a stick, I hit that tube. Look at it. Jeez. I really thought I had solved this, but no. Okay, we're gonna have to assume that that is the way it was when we started. And so bogus test in every direction. But and did I touch that volume control? Did I touch the volume control? I'm going to try to write with this stick. Here, get a pencil. Okay, 400 hertz. Where it is right now, I will tune the radio slightly and then return it back. And the objective here is to find out if there's a peak higher than the 5 on the meter, on the meter, on the meter. It's pointing at 5. Tune the right knob, Jim. You know what? It was like this. You could hear ever so slightly some harmonics. Gone. Okay, so we're gonna tune it dead center here. Sounds beautiful to me. That's a nice hum. 400, and we would be at point 1. So point 1 is over here. So this is 0.055 at 400. 0.055 5. Okay, now we'll go to 1,000 hertz here. Yep. 1,000 hertz, the number we get is 0.034, I would call that. 0.034, and then we'll go to 5,000. Somehow you kind of imagine the higher frequencies are the things that would get robbed as the radio weakens. And so if I've restored it at all, this is where we would expect to find a difference, I would guess. And what do we get? We get 20, looks like 29.5, 0.029, 0.029. Dun, ta da ta. Here's the exciting result. Okay, that's the frequency, 1,400 and 5,000. This is before, this is after. Before, 0.028, after 0.034. 045, 055, 024, 029. This is the high frequency one, and I thought we would see more effect. The difference between this number and this number is probably far less than the differences caused by all the shenanigans in here anyway, so. But generally speaking, they all went up. It could be as easy as that. The great compensator, which people call a volume control, but really it's a compensator. It compensates for weaknesses in your radio. Let's listen to something on FM here, and then we'll call it quits. One capacitor. Didn't get much done today. Let's get this right off here. Don't go flying in there. The clip lead danger. Boy, I'm lucky that time. So this is the rabbit ear antenna I have suspended from my ceiling there, if you can kind of see it. That's what we're going to listen with. Don't start falling over. I'll put this right on here. Just clip it here. So it's picking up the signal generator. So we're done with the signal generator, and I'm going to switch it off. Oh, this is a good sign. Right knob.
Create a sucking sensation. Create a thirst.
Huge volume here.
They believe to cleanse the system. It came to mean the whole idea of dedicating or setting apart. Cultivation first. So right away we're disarmed. The parent's immediate task is to create.
I find with these FM radios, these older ones, you need to carefully tune them dead on, or you get a little bit of distortion.
When children are born, we do what we can to cultivate a thirst. Please observe the next phrase, a child in the way he should go. This word for child is used across the board for all ages of children living under the...
Now that's a religious station up here. Let's find some music. I'm going up band. Nothing. So there's some distant stations up this way. Distant being in Toronto. Oop, wrong number. They're not showing up. This might actually not go high enough because it's 106. That's 106. Yeah, I would go high enough. Let's go down. Wow, it's so quiet. Where'd that...
Rebels of the neighborhood.
Right there. One station? This is the God receiver. That's probably 95.7. That should be very strong. 90, 94, 95.7 would be over here. Wow. What's going on here? That it just receives one signal really well. Yeah, that sounds distorted the whole time. I couldn't tune out the distortion there. I need another music signal. It's a weak signal, it sounds distorted too.
Putting some energy into your work. The 93 lunch break. Fresh 93.1.
93.1. So we're there. Terrible distortion. I have full voltage on the radio too. 120 volts or so. And then there's this whopper. What goes on right there? This signal is normally weaker than the ones down here on radios. This is not a powerful station, but this radio thinks it is. So I think the next step, more capacitors to change. You know what I might want to do at this point is do the tube testing on this and go through the tubes and test them. It's possible the FM tube up here is weak. Something's going on. Something funny is going on. So, okay. But that's all for today. One capacitor. Oh, man. Thanks for watching.